Okay, so our next unit is going to be surface area. Before we get started, make sure that you have updated your table of contents with your title surface area and today's date. My date today is April the 15th. If you're watching this in the future, your date may be a little bit different. We're going to start off by talking about some vocabulary. The first vocabulary term you should already know from our volume unit. Capital B, or as we call it in class, Big B. Big B stands for area of the base. Hopefully you remember that from our volume unit. So if we have Big B, we learned in our volume unit that everything that we did cylinders and cones. So the area of our base was always a circle. And we find the area of a circle from pi r squared. Well, in our surface area unit, our base could also be other shapes. It could be triangles, it could be rectangles. So in addition to having a circular base, we could also have triangular base. And then to find the area of a triangle, if you remember from last year, is 1/2 base times height. Notice that's little b, that's a base measurement. This is capital B, big B, it's a calculation. All right, and then the third shape that we could have is a rectangle or a square. Square is a type of rectangle. And we find that area by finding base times height. So again, we had bases of circles in our volume unit. Now we're going to be adding in shapes, three-dimensional shapes that have triangular and rectangular bases as well. So the next item, vocabulary term, is a capital P. And just like Big B, we call it Big P. Capital P. That stands for perimeter of the base. Perimeter of the base. Remember, it's a capital letter, so it means we have to do some type of calculation. So going back and looking up at these shapes, remember, these are all area formulas, but we have different ways to find perimeter. So if our shape was a circle, remember the perimeter of a circle is also called the circumference, which uses a different formula. Not pi r squared, but circumference uses pi times diameter or 2 pi r. You can verify that with your formula chart. If your base was a circle and we needed to find the perimeter, a triangle, and we needed to find the perimeter of the base, we would add up all three sides. Same with a rectangle. If we needed to find the perimeter, that's the distance around the base, so we would add up all four sides. So perimeter is the distance around the base. Distance around the base. Okay, so that's our first two vocabulary terms. Capital B, area of the base. Capital P, perimeter of the base. The next vocabulary term is we need to define what is surface area. Surface area you can think of like wrapping a present. You're covering all the surfaces of that present, right? Or maybe you want to paint a vase. If you're painting a vase, you're just painting the sides, right? You don't paint the top and the bottom. So there's two types of surface area. The first one is called total surface area. And it's defined exactly as it says. It's total. It's the area of the entire 3D figure. And that is including the bases. Including the bases. Okay? So total surface area, area of the entire 3D figure. So that would be like wrapping a present. You're covering the entire box or the entire present in wrapping paper. Okay? The next one is lateral surface area. Lateral surface area. And these two are real important to know the difference between, because questions are going to ask you to find total surface area, or they're going to ask you to find lateral surface area. misspelled that. And lateral surface area is the area of the 3D figure, but not including the bases. So area of the 3D figure, but not including the bases. You might want to highlight that part, not including the bases. Highlight it, put a box around it, something to make it stand out. So we have total surface area and lateral surface area are our two vocabulary terms. And we're going to draw pictures in just a few minutes that will help visualize total surface area and lateral surface area. Okay? It will also help visualize the parts to a 3D shape, which we're going to talk about next. So the first part to a 3D shape is called a face. A face. A face is the flat surfaces of a 3D figure. The flat surfaces of a 3D figure. So basically the sides, if they're flat. The flat surface of a 3D figure. And then the last vocabulary term for today is going to be bases. What are the bases of a three-dimensional figure? Well, the bases, remember when we talked about cylinders, the bases, those circular bases were kind of like the top and the bottom, or the two sides. So to define the bases, first of all, we know they must be congruent. So if you remember, congruent is same size, same shape. So they must be congruent. They also must be parallel and not touch. They must be parallel to each other and not touch. They're on opposite ends of the 3D figure. Also, the two bases are connected by the height of the 3D figure. So the height is always the distance between the bases. And I'm going to rewrite that so we have that in our notes. The height that connects our bases, connected by the height of the 3D figure. So in other words, it is the distance between the bases. The distance between the bases is the height. The distance between the bases is the height. So again, might want to highlight those vocabulary terms, faces and bases. Once we do our drawings on the next page, you'll be able to see exactly how those faces and bases relate to each other. We'll also be able to better understand what we mean when we talk about total surface area and lateral surface area. Alright, I'm going to turn the page over because I'm out of room at the bottom. Alright, so now we want to talk about drawing the shapes and identifying, identifying those vocabulary terms on our shapes. Well, we pretty much talked about cylinders and volumes, and we'll get to that today as well. But the first type of shape that we'll be using with three-dimensional and surface area is called a rectangular prism. A rectangular prism. Alright, so we're going to draw this rectangular prism. I'm going to come down here and I'm going to draw a rectangle. Then I'm going to scoot up and over, and I'm going to draw another rectangle that's about the same size, trying to make those congruent. Then I can connect the corners, bottom to bottom, top to top, bottom to bottom, top to top. And there is our three-dimensional rectangular prism. And remember, rectangular prisms can come in all sizes. Here I have a long, skinny rectangle. I could have a short rectangle but being tall. Okay, I could have my width being small and my height being tall. All right, now let's look at this rectangular prism. If I decide that this is one of my bases, this front side, then where would be its other base? Remember the conditions. The bases must be parallel and not touch. They must also be congruent. Right, so then that means this back side would also be my base. And if you remember from previous years, we call this a rectangular prism because my base shape is a rectangle. So there's one of my bases, and there is my other base. So I have my two bases here. And then if you remember from our vocabulary, the distance between the bases, right here, that would be considered our height. The distance between the bases that connects the two bases, that is considered our height. Now, the special and unique thing about a rectangular prism, if you notice, all sides are rectangles. So I really could make either side's pair of sides to be my bases. Really, in a rectangular prism, the bases are decided by who's creating the problem. So I'm going to show you an example of that. Let's do another, we're going to draw another rectangular prism that looks just like this one. So a rectangular in the front, a rectangle in the back, connect my corners. So they look the same, but now we're going to make our bases be different. Instead of being the front and the back sides, what if I did the bottom here as my base? What if I shaded this bottom part as my base? So my base right here would be the bottom. If my base was the bottom, where would be my other corresponding base? Remember, they have to be parallel and not touch, and they have to be the same size, same shape, congruent, and they're on opposite ends. So if the bottom is the base, then this top side would also be the base. Be a little bit harder to draw it in, it'll start to get a little messy. But if I shaded in this top part, could also be the base. So I could have the bottom and the top as the base. If my bottom and top are my bases, then my height would be this distance right here. The distance between the top and the bottom would be my height. Okay. Let's draw one more rectangular prism. Same thing. I'm going to draw the rectangle. But this time I want to see what would happen if we made the sides our bases. Not the front and back, not the top and bottom, but the sides. So what if instead of not the front and back, not the top and bottom, but what if I did this long skinny side as my base? What if I did that as my base? Where would my other base be? So if it's this side, my right side, the corresponding, the other base is our left side right here. Which is a side. And then if those two are my bases, where's my height going to be? Where can I show the distance between the bases that connects the two bases? Right, this measurement right here. height. I could also label it back here, because remember, the opposite sides are congruent. So that is still the same distance. It is still the height of that prism. Okay? So again, it doesn't matter on a rectangular prism which side is considered the base. It all depends on the problem and who's creating it and what they determine is the base of the rectangular prism. Okay? The next shape we will have in this unit is a triangular prism. And a triangular prism is a prism similar to the rectangular, except our bases are no longer rectangles, they are, you guessed it, triangles. So I'm going to draw my two triangles, connect my sides, corner to corner, top to top, corner to corner. Now, in a triangular prism, because remember, a prism is named for its bases. It's a triangular prism, so that tells me my bases must be the triangles. So here's the base here, and here's the second base. Now remember, a prism could be turned around. I could also have it laying on its side. It's still a triangular prism, no matter which way we turn it. It has two triangular bases. Okay? So it has two triangular bases. If it has two triangular bases, then where can I find the height? Remember, the height has to be the distance that connects the two bases, the distance between. So my height would be right here, the distance between the two bases. I could also label my height right here. It's the distance between the two bases. Those are going to be the same distance because if you look, this face or this side is a rectangle. And we know opposite sides of a rectangle are congruent. Okay? And then the last shape, we are still going to be talking about cylinders. We are still going to be talking about cylinders. And this one should be pretty familiar from when we did volume. So again, on a cylinder, we know we have a circular base, top and bottom. Those are our bases. And then our height, of course, is the distance between the bases that connect them. So that would be our height. Now, I told you we'd also talk about the faces and bases. Remember, faces are any flat surface of our three-dimensional shape. So in a rectangular prism, every side is a face. Every side is a face. Now, the two sides that are opposite and parallel that we call the bases, those are just special faces. Those are what we call our bases. Here it was top and bottom, side and side. Same thing with a triangular prism. Our faces are generally considered the sides. They are flat. And we have our two bases. Now in a cylinder, we have our bases here. All right, please make sure you get these notes down in your spiral. We will be needing these as we go forward in the unit. And I'll see you on the next school day.